Hi, my name is Asmira binti Jimis. My metric number is HFT20203. Today I want to explain about part A. Number 1. Explain the sampling technique used and type of data and level measurement. The sample technique used is sample random sampling. The type of data used is quantitative variable, and the level of measurement used is interval scale. Number 2 is construct three appropriate tables that can be used to describe the data. Data arrangement. This is the number I pick from appendix to describe the data. 2.1 is frequency distribution. N is equal to 50, so 2 power k is greater than 50, and after trying some number, 6 is greater than 50. Therefore, we can say that the class for the data set is 6, which is greater than 50. To get the class width is the maximum entry minus the minimum entry divided by 6 equal 9.83, and I round up to 10. For minimum data entry, 13 is conventional lower limit for the first class. To find another lower limit at the class width of 10 to the lower limit of each previous class. For example, the upper limit of another class is 32 plus 10 equal 42, and 42 plus 10 equal 52, and so on. The next is the relative frequency. So, the relative frequency formula is the frequency divided by the sample size. For example, 3 divided by 50 equals 0.06. 10 divided by 50 equals 0.2. And the next relative frequency is 0.18, 0.2, 0.22, and 0.14. And the total relative frequency is 1. Number 3 is the cumulative frequency. The formula for the cumulative frequency is cumulative frequency plus the frequency of the second class. For example, the cumulative frequency is 3 plus the frequency of 10 equal 13. 13 plus 9 equal 22. And the next cumulative frequency is 32, 43, and 50.
Hello, today I'm going to talk about question number 3, and that is developing two suitable graphical methods to represent the data using graph, paper, or Excel. 3.1, I use OGIF, which its horizontal is upper class boundary, vertical is cumulative frequency. The plot point that represent the upper class boundary and their corresponding cumulative frequency that connect the point in order from left to right. And the graph should be start at lower boundary of the first class, and that is cumulative frequency, and should end at upper boundary of the class. For 3.2, I use frequency polygon, which the horizontal scale is midpoint of the data value, and the vertical scale measure our frequency of the class, and the plot point that represent pinpoint and frequency of each class, and connect this point in order from left to right. So, for question number 4, find an example. The value, measurement of center tendency, measure of position, and measurement of variation. Hence, determine the shape of data distribution. For 4.1, that is measure of center tendency distribution. To find it, you must find the frequency of class, the midpoint of a class, and the total number of entry in sample, which is n. To find it, we have to combine the f times the x, which you get 2,245. For the total number of entry in sample, which is n, is 50. So 2,245 divide by 50 and you get 44.9. To find medium, you have to find the location of the medium class, which is the 20th. Therefore, the medium class is 43 and 52. Next, you need to find the lower class boundary, which is LM, and that is 42.5. For class with that is C, you need to minus 52.5 minus 42.5, and you will get class with 10. And to find the cumulative frequency before median class, it is 10, and the frequency is 10. And the formula is LM, and that is lower class boundary of median class, divide by 25, 10 per 10 times 10, and you will get 57.5. For the mod, you need to locate the model class, which is 53 to 62. For the lower class boundary, which is LM, is 52.5, and the width class is 10. The difference between frequency of model class and frequency before model class is 1. For difference between frequency of model class and frequency after model class is 2. By putting all together into the sample of mods, you will get 52.5 plus 1 plus 4 times 10, and you will get 44.5. For 4.2, measure of position, you need to find the Q1 and QT. For the location of Q1 or Qi, we need to put 1 open, 50 close per 4, and we will get 12.5, which is the location of Qi, and the class, therefore the class interval is 23 to 32. For location of Q3, you need to put 3 open, 50 close per 4, and you will get 37.5, and therefore the class interval is 53 to 62. And now for the quality Qi, which is 22.5 plus open 12.5 minus 3 per 10 times 10, and you will get 32. That means that Qi is 32. It means that 25% spend their recent session less than 32, and 75% spends more than 32. For Q3, you need to make 52.5 plus 37.5 minus 32 per 10 times 10, and you will get 58. Therefore, that 75% spends their recent session less than 58, and 25% spends more than 58. Now, try to find the measurement of variation. For the variant type, you need to put 1 per 50 minus 1, open, that 1,041,235 minus 20,245 times 2 per 50, and you will get 19,192.336. For the standard division, you need to find the square root. So, square root 1 per 50 minus 1, open, 1,041,225 minus 2,245 the power of 2 per 50, close, and you will get 138.536. Now for 4.4, and that is determine the shape of data distribution, and which is the mean is 44.9, the median is 57.5, and the mode is 54.4. It means that it is a normal distribution of the data. Thank you.
Hi, Assalamualaikum. My name is Nurdiana Syaira binti Kamrul Zaman, entry number H22A0912. Now, I want to present about find one set data that have one independent variable and one dependent variable. H is an independent variable and net facts is a dependent variable. Sample size refers to the number of observation or data point in a dataset. Here show the sample size is 13 because there are H is 13 different net fact. Next type of data, quantitative data is numerical data that can be measured. The independent variable H is quantitative because it is measured in numerical minute. Therefore, the dependent variable net fact is quantitative because it is a numerical percentage. And last, level of measure. Interval level means that the data point have a definite numerical order, the same distance between them, and allow specific body mass index BMI operation. Specific H are interval level because H can be ordered, added and subtracted, and spaced equally on the scale. Test score are also interval because percentage can be ordered. Mathematical operations are used, and equal distance are measured on a 0 to 100% scale. But interval data has no real 0 point, unlike ratio data. In summary, the sample size is 13 people of different age. Both variables are quantitative data type measured on an interval scale.
My name is Ada Nilimashi binti Azinumashi and my metric number is H2TA0142. As you can see, I have chosen 30 people randomly from the age of 90 to 59. So, N is 30. Next, the following table shows the list of ages that have been selected and categorized as X. While in this section, we choose to study the net fact from each of the 30 people who randomly selected and it was categorized as Y. To get X squared 2, each which is 37 needs to be multiplied by 37 and get a total of 1369, as well as squared 2. While for xy, h is multiplied by net fact. Example, 37 multiply 13.5 and get 499.5. After counting everything, x needs to be total and get a total of 801 and so on. Y 158.1 x squared to 24,300 and y squared to 938.02 and xy is 4,313.1. After getting them all, the sum total will be the use in the next count. As you can see, the formula. This count is used to interpret the strength of the correlation coefficient. From the result of the calculation that I found, it is weak positive correlation, which is 0.1661.
My name is Nurul Farhana binti Nadi Syukur and my metric number is H22A0472. Firstly, the table on the left serves as a reference for answering the question. The age in the table is X and the net fat is Y. H or X must be raised to the power of 2 to find X power of 2, and X must be multiplied by Y to find XY. Finish the calculation and find the sum of each. We must calculate according to the formula. The regression equation formula is estimation Y equal data naught plus data 1x. Refer to the second picture to find the amount of data naught and data 1. And finally, for the interpretation is the estimate regression equation of data naught is 4.43 and the estimate regression equation of data 1 is 0.0315. The estimate regression is the estimate Y equal to 0.0315 plus 4.43x.